Greetings and welcome to this 3D Motive comprehensive course on creating a box-pushing puzzle game in the Unity engine. I'm Alan Thorne and I'll be your instructor as we explore how to build a 3D puzzle game every step of the way from start to finish. Throughout this course we'll take an in-depth look at a wide range of Unity features, from level design and lighting configuration to inverse kinematics, character animation, and also load and save game functionality. In this second part of the course, we'll dig deep into the world of character and humanoid animation using the Bones and the Mechanim system. Here I'll show you how to import and configure rigged characters into Unity for an optimal workflow. We'll explore avatars, muscle definitions, bone hierarchies, Mechanim state machines, and how to create input mechanics to get the player character moving and responding in-game. By the end of this part, you'll have developed a solid understanding of Unity's character animation features that'll increase your game development leverage. So, let's go. So to get started with this section of the course, I want to start by examining the imported character mesh. Now, we imported the character mesh in the previous part of this course. It is a rigged character mesh in the FBX format, and that was imported to the folder here, Assets, Meshes and Character, and you can see the character mesh here. I'm going to select that in the project panel. This file is included in the course companion files in the Assets to Import folder if you've not imported it already. Now, because this is a box pushing game, we're going to need a character to represent the player in the level, which is going to be pushing the boxes onto their destinations, and this character will also be animated using skeletal animation. Now, the model, the rigging and the animation data have been prepared already for us using 3D animation software, and all of that data is already baked into this imported mesh file. All that remains for us to do is to configure this mesh in Unity. So the first thing I want to consider is the mesh scale factor, which you can see here in the object inspector, and also the constituent pieces that make up our mesh. So first of all, you'll see here in the project panel I have the mesh character selected, and there is a little arrow pointing to the right hand side. Now, by clicking on that, I can unfold all of the different pieces that are baked into this model here. We have the skin, the hair, the clothes. We also have this box that's been included, and you can see that here in the preview panel this character has a box mesh that's been imported with it. Now, this is effectively a reference for us. Later on we're going to be hiding this box mesh so that it won't be shown in the level, but the box mesh has been included for us, as we'll see soon, so that we can use it as a reference for positioning the real box in the scene. So I'm going to leave the issue of the box at the moment. Just know that it's been included in the mesh file. It's not actually attached to the character mesh in terms of geometry. It's a separate object. You can see it listed here in the file as a separate object from the rest of the character mesh. We also have this take 001, which represents all of the animation data on the timeline in the file. Again, we're going to be working with that very soon. So I'm just going to fold this back for now, and I want to concentrate on the scale factor. Right now you'll see the scale factor is 0.015. I've gone ahead and set this value off screen. Now, typically I've recommended that you use a scale factor of 1, but sometimes when you're working with pre-made assets, as the case here, we don't always get the nice round number scale factors that we want. And sometimes we have to use a bit of trial and error to choose the right scale factor that will get our mesh to the right size in the scene. So if I drag and drop this character mesh in the scene and I sort of position her down by the floor level, you can see that a scale factor that we've chosen here is about right for this character mesh to get it the right size for the rest of the environment. So that's looking pretty good. So I'm just going to delete that here. So just know that for this character mesh I'm using a scale factor of 0.015, and that works fine for this character. Okay, with that said, let's move on and consider the rigging and animation data for this character. Now, in this movie I want to get started at considering the issue of rigging, or the rig for the character. You will see that when we import the character mesh we have a second tab here in the object inspector which is tabbed rig. Now, rig refers to the underlying bone structures inside this character mesh that the animator has put there for creating the animation for this character. So underneath this mesh here, there is an invisible bone structure which defines how the character moves, and the model, the vertices of the model, will conform to the underlying character mesh, the skeleton, as it moves across the timeline. So we can't actually see the skeleton structure here, but if I drag and drop the model into the scene, like so, you'll see the character listed here in the hierarchy panel. And the first thing you'll see is that there's a little twirly arrow next to the character, which means that we can open it up and examine it even further. So I'm going to do that here. I'm going to open up the character, and you'll see straight away that we get different pieces to this character. Let me just press F on the keyboard to zoom in and focus on this character here. So we get different pieces that we can see in the hierarchy panel. We have the clothes for this character, and that immediately creates a separate selection for the clothes. We have the hair, we have the skin, we have this what's called a reference base. This is an object that's been named by the animator in the scene. But if I open this up, we can go even further, and I can select the cube mesh here. Again, I can also move and transform it completely separate from the rest of the model. But now if I dig down further into root base, we begin to access what is known as the skeletal structure for the mesh. So again, I can twirl this open and we get hip, we get spine, and again I've got more spine bones. I've got a hip bone, a femur bone, a knee bone, and these all correspond to different parts and joints on the model. And this structure together defines how this mesh animates. Again, we can transform this separately, and notice that I'm just transforming this particular area of the mesh. I'm not transforming the whole mesh, I'm just deforming the bones. So again here I can adjust particular bones and pieces of the mesh. Right now the deformations are looking really quite terrible, but you can see that by using this hierarchy panel here, I can access each of the bones that are embedded inside the model. These bones refer to the rig. So I'm just going to select this model and delete it from the scene, and return back to the character mesh here and look at the properties in the Object Inspector. So we have this rig tab here, and we have the animation type, which by default for pretty much every model is set to generic. Sometimes it may be set to legacy, and maybe even to none. Now if we have it set to none, it defines that this mesh has no rig at all. If it's set to legacy, then it's a structure that is compatible with Unity's older animation system. And generic refers to pretty much any kind of rigged structure that is not a humanoid. Now a humanoid is any human-like structure. Now in this case we know that the skeleton is for a character, so it will be a humanoid. So I want to change the animation type from generic to humanoid, and this will allow us to access all of the more advanced Mechanim features. So I'm going to switch it to humanoid and then press apply on this toolbar here. And when I do that, this Object Inspector changes. We get a little tick icon here next to this configure button. If this tick icon appears, it means that Unity has gone through the bone structure of this mesh, and it has managed to determine that it is indeed a humanoid skeleton. It has gone ahead and found all the necessary appropriate bones inside this structure and configured them automatically into a special structure known as an avatar. You can see the avatar definition here. And avatars are what we're going to be looking at next. In the preceding movie, we examined how this character has a bone structure, and we have configured it using the animation type in the Object Inspector to give it a humanoid setting. This will allow us to interpret the model and to tell Unity that this model is a character mesh. So what we're going to do next is we're going to be having a look at what's called the avatar, and the avatar is a special Unity structure. It creates a mapping between how the bones influence the vertices in the mesh. It is a skinning kind of structure. It will allow us to map a single set of bones onto a character. Now it just so happens that this character that we've imported here comes with all the bones and the skinning information built in. But there might be times when you want to reuse the skeleton for this character on a different character, and avatars can help you do that. That process of reusing an old skeleton on a different and new character is called retargeting. But right now, let's just take a look at the avatar for this particular mesh. We can do that by clicking on the Configure button here in the Object Inspector. So I'm going to click on the Configure button, and this straight away displays the Avatar Definition Editor, which is part of the Mecanim animation system. So right now you can see we've got this, if I zoom in here, we've got this character mesh in the viewport. And straight away you can see highlighted in green are the bones for this character. And right now on this side you can see we've got this character definition here, we've got an image of the character and it's all highlighted in green, which means that Unity has gone ahead through our bone structure in the hierarchy panel and successfully picked out all the relevant bones and mapped them onto this structure here. If I scroll down you can see that we've got the different bones of the body. For the body here we've got the hips, the spine, the chest. Again we've got particular bones for the shoulder, the upper arm, the lower arm, and all of these correspond to particular objects that we can see here in the hierarchy panel. So for example, for the upper arm here, for the left arm, Unity has set this bone here, has found this bone in the hierarchy, and you can see here in the viewport that it is indeed the upper part of the left arm. So Unity has been really smart. It's managed to detect all of the bones in this structure and map them onto the right places here in the editor. In fact, I can use the transformation tools here in the editor to start to rotate the bone. You'll notice I'm getting these red error messages, character is not in T-pose, but that's absolutely fine for now. We're just testing this. Again, I can rotate this bone and notice that the arm here is deforming properly for this bone. So again, I can move the arm forward. I could rotate the head a little bit. And notice that the deformations now are working really quite nicely. So I can select this one, bend the character forward, and by animating and adjusting these bones, I'm starting to pose this character here. So again, if you're not happy with this arrangement, if you're getting these red error messages, you can easily enforce the T-pose by coming down here and choosing Pose and Enforce T-pose. And that resets the character here. But again, things are not quite set back to as they should be, but that's not a real problem either, because I can choose Revert. And again, it reverts the character back to their default settings. So you never really need to worry about creating an irreversible deformation here. So we have all of these bones set up in the hierarchy panel, and they've been mapped to the appropriate place. Sometimes parts of this model here might appear in red when Unity can't detect which bone should go there. But you can easily fix that. You can just drag and drop the right bone that you need, drag and drop it into any one of these bone slots to create the mapping for yourself if you need to. But we've been really lucky here, or well, not lucky, Unity's been really smart. It's managed to work out all the necessary bones, and this character is mapped nicely, automatically for us. And it's pretty good at detecting most character meshes, so you shouldn't need to worry too much about the bone mapping here. This is looking pretty good. So I'm happy with how this is for the moment. Next we're going to be switching over to this second tab here, which is the second part of the avatar definition, which considers the muscles. Right now we're in the middle of defining the avatar for our character. In the previous movie we concentrated on the mapping section here, which allows us to pick out the bones for the skeleton in this hierarchy here in the hierarchy panel and control how they map onto these various bone sections here for the avatar. Now we know that the bones in the model define its structure. They define all the different joints and hinges in this structure on which the character will animate. Now we want to concentrate on the muscles, and what the muscles do are they define how these bones in our hierarchy relate to the vertices in the mesh. It may be the case that we want to take this skeleton and reuse it on different characters. Well, some characters are tall and thin, like me, and some characters are really big and fat, like Shrek, for example. So we might want to reuse the same skeleton on both characters, but because the characters are completely different sizes, the vertices of the mesh will be different distances away from the bones, and so the mapping between the bones and the vertices will change. What the muscles category does is it allows us to control how the bones relate to the vertices. This process in other applications is often called skinning, but Unity calls it muscles. So let's take a look at how the muscles tab works. So I'm going to switch over now to the Muscles tab, just by clicking on the Muscles tab here, and already the character has changed its pose in the viewport. So let's just scroll down in the viewport and just take a look at this pose here, and you can see that it's slightly hunched over and bent like so, and it's in this kind of pose that we've got here. Now, of course, I can start to change these poses. I can say, for example, we have this open and close pose. So I can just scroll this slider in and out, and you can see that's what's happening is the character is being posed between different extremes. So the bones are stretching out this way, and then it's being crunched up this way here. So we're really controlling the sort of extremities of the character's posture. And what we're looking for in particular when we do this is we're looking to see how the deformations are happening, how well this character is deforming in its current configuration. So we have a left and a right pose, which controls again the character stretching in either direction. We have a sort of roll left and roll right pose. We have an in and out pose. We have this roll in and roll out, finger open, finger closed, and so on and so forth. So I'm just going to reset all of those poses there back to their defaults. Things are looking okay for this character mesh, but it might not always be the case, particularly if you are reusing this skeleton for a different character. Let's just open up, for example, the head section here, the head slider. Maybe open up this left arm slider, and let's take a look at what's going on here with these muscles definitions. You'll notice that now when I slide between the open and close pose up here, the sliders down here are actually changing, and that's because these presets here are controlling how these sliders work. So when I slide between the open and close pose, you can see that the sliders below in the per muscle settings are also sliding to their different extremes. So what exactly is going on here? Well, let me just reset this back to normal. Let's take, for example, just the head pose here. Let's have a look at the head, the neck nod down and up. So when I start to control this slider, we get the head looking up and the head looking down. So I'm just going to reset that back to its center. Let's take a look at the head tilt left and right here. So we've got the head tilt left and the head tilt right. So now let's say, for example, that I'm not really happy with these settings here. I want to perhaps increase or decrease these settings. So what I can do is open up this neck tilt left and right, and we have this slider here. Let's just move, for example, the head to this extreme here. So the head is tilting to the far right. Let's say I want it to tilt further than that. Well, I can control this right hand slider, and ooh, see, now I can really affect the extremities of this. Now the head is upside down. So let's say I want to again limit this effect. Let's say about there is the maximum. So now when we're on that extreme, that is the maximum tilt that we can have for this mesh with this skeleton. Let's see what the left hand side is. Well, yes, okay, let's say I want to reduce the left hand side. So again, I can bring in this left hand slider and again see the mesh changing in the viewport. So what I've defined here is the range of deformation for the neck tilt left and right animation. So now these are the extremities that this model can be deformed. This is how much these bones can deform this model with regards to the neck tilt left and right. And we can apply a similar process to the nod up and down. So let's move over to the side again and take a look at this. So again, we've got the neck tilt up and down like so. Well, of course, that's actually looking. We've now configured an avatar for our character, so it's time to configure its animations. Now for this character there are actually going to be 4 different animations. These will be idle, cheer, walk and push, and we'll see these in action very shortly. So I'm going to switch over here to the animations tab, and what we have here on the animations tab, if I scroll down to this section here that says clips, is take 001, which ranges from frame 0 to frame 250. And if I expand the character mesh here, you can see the take 001 animation data. And this refers to the complete timeline of animation that is baked into the mesh file. And in fact, if I press play on the toolbar here, you can see in the preview that this animation is being played. So there we have a quick animation of idle and cheer and walk and push. And so we have those animations that are now playing in the timeline. And of course, the speed of these animations doesn't really matter. I can slow down the speed if I like. Right now it's playing at twice the normal speed, but let's just put it down to 1, which will play at the normal speed, the default speed specified in the file. So we can see those playing here at the normal speed. So we have the walk animation, the push, and there we have it. Now all of these animations right now, they're all lumped together on one single timeline that is embedded in the file. And of course we want to play them all as separate animations. So we want, for example, we want the walk animation, that's going to be one separate animation. The cheer animation, that's going to be separate. We're going to need to separate all of these animations out now. And we're going to be doing that using this clips tab up here. So I'm going to get started by creating our first animation clip, which is going to be the idle clip. Now this is the animation that spans a lot of our timeline, and this is the animation that's going to play when the character is standing still and doing absolutely nothing. So let's just go back up here to the take, and I'm going to rename this first take by selecting it and then clicking here in the take box, and I'm going to rename this to idle and press enter on the keyboard. Now it just so happens that because I have access to the original animation file and the animation data, I know the frame numbers that represent the start and the end of the animation. So the idle animation begins at frame 0 and it ends at frame 143. So I can scroll down here and you'll see that we've got the start frame, which is going to be at frame 0, and the end should be 143. So I'm going to type in 143 like so, and you can see that what we've got here is suddenly this animation timeline has changed to the range of the animation. So this represents the complete animation timeline, and the idle animation spans this range. And we've got these green checkboxes, these green lights that illuminate to indicate that Unity has found a matchable and loopable animation. So the end frame 143 matches up with the start frame 0. I'm going to enable loop time to say this is a loopable animation, and I'm also going to click loop pose here so that Unity will apply whatever transformations it needs to try and create a loop between the start and the end. And that really configures our first frame, the first animation clip, which is the idle clip. So I'm going to accept all of those changes and click apply. And when we do this, it now creates an idle clip, and you can see that now listed here in the mesh file. This has changed from being take 001 to idle. And in doing that, what we've done is create our first animation clip. So now we need to create the remaining 3 animation clips for the walk, the push, and the cheer. Now in this movie I want to configure the remaining 3 animation clips that we need to create for our character mesh. To get started, I'm going to just move over to this object inspector here, and since we don't need any of this data on the left hand side, we don't need to see the hierarchy panel or the scene panel or the project panel, I'm just going to move my mouse over the inspector and press the space bar on the keyboard just to maximize this view and just to see it in more detail. I like to have as much screen space as possible. Now of course we can see here listed in the clips section we have this idle clip that we've created, and if I press play on the toolbar we can see the idle animation playing. It's pretty subtle, so you need to keep an eye on the arms in particular to see this in motion, but this is the clip that will play when the character is doing nothing at all. But of course we know that the animation timeline spreads from range 0 to 250, which is longer than what we have specified here for the idle clip, so there are more clips to create. The next clip I want to create is the cheer clip. So I'm going to press the plus button here on the clip section to add a new clip. And I'm going to change this from take 001 to cheer and press enter on the keyboard. I'm going to scroll down here and specify the start frame of 144 and the end frame is going to be 192, like so. Now we don't need to worry about this animation being loopable. If I press play on the toolbar you can see the cheer animation, there we are, taking effect. Yippee! But of course we don't need to worry about this being loopable because this will only ever play once. We won't be looping this animation at all, so I don't need to enable this loop properties here at all. So that's absolutely fine. We can go ahead now and create the next animation clip. Next up, I want to create the walk and the push animations for our character. So let's get started on doing this. I'm going to create a new clip by pressing the plus button, and I'm going to name this walk, like so. And of course we need to define the start and the end frames for the walk. So the start frame will be 194 and the end frame is 217, like so. And again, we've got these icons displayed here, the loop match between the start and the end frame. We know that in the case of walking, this should be a loopable pose, because the player may hold down the forwards key, for example, to continue walking over time, and we need to loop that walkable animation. So I'm going to enable the loop time checkbox, and I'm also going to enable the loop pose checkbox, and I'm going to scroll down here to the field that says root transform position, and I'm also going to enable the bake into pose field to help keep this character grounded onto the floor. If I now press the play button on the toolbar, you can see in the preview animation we now have this character walking away, and this isn't looking too bad at all. So we've got this character walking, and that's looking okay. So I'm going to leave those values there at their defaults, and I'm going to choose apply. Let's just scroll down, choose apply to create those clips there. So we now have the idle, chair and the walk clip. The final clip I want to create is the push clip, which is going to be played when the character pushes the box. So I'm going to press the plus button again, and I'm going to name this one push, like so. I'm going to scroll down, and again the start frame for this clip is 220 and the end frame is going to be 250, which is already at that value. The loop match values here are enabled, and again the character could be holding down the forwards button when pushing a box, so we want this pose to be loopable. So I'm going to enable loop time and loop pose, press play on the toolbar. Let's just see this animation in action, and there we are. This frame is now playing and this character is pushing the box, and it's looking pretty good, I think. So I'm pretty happy with how that's looking. So I'm going to accept these values here and just scroll down and press the apply button. And so now what we have is we have our 4 clips here: the idle, chair, the walk and the push. These are all the clips that we need here for this character. So I'm pretty happy with how everything is looking. So I'm going to leave this all as is, and we're ready then to move on. We've now configured the rig and the muscle definitions and all the animation data for the character that we're going to be using in our box pushing game. So it's time to insert that character into the level and to start to get it working and the animations playing in game. So let's see how to do that. I'm just going to press stop here on the preview panel and just move over here into the scene, and I'll add the character to the level. So I'm going to drag and drop the character just anywhere into the level, like so, and I'm going to reset their position back to the level beginning here. Let's just find them in the level and take a look at how they're oriented. So they're positioned there in the level. That's absolutely fine. It doesn't really matter right now where they're positioned. I just want to get the animation data playing. You can see that automatically when I add this character to the level that an animator component has been attached to the character. Now let's just take a look at how this scene works in game. What I want to do is just move my viewport to around about there so that we can see the character quite clearly. I'm just going to select the camera in the scene, and I'm going to choose game object and align with view to align the character with the view. As I do that, you will see over here in the camera preview that the camera will align to the viewport here, as it does, so that now when I press the play button on the toolbar, we can see the character clearly in the scene. And you'll notice that straight away no animation is playing on the character at all. The character is perfectly still. And the way we control the animation logic that is playing on the character is to use an animator controller, an animation controller, beg your pardon, an animation controller asset. So let's add one of those now. I'm just going to stop playback here and move over to a folder that I've created here with the assets. I've created a folder called animation, which is going to contain all of the animation data that we create for this character. So I'm just going to open up this folder, right click in the project panel, choose create, and somewhere in this list, unfortunately it appears outside the recording window, but that's not really a problem. I can come up here instead to the file menu and choose assets, create, and in this list you will see animation controller. Careful, there are some other things that we can create. For example, we could create animation, or we could create animation override controller, but no, I want to create an animator controller like so, and we can see that here in the project panel. I'm just going to name this to char controller and press enter on the keyboard. When I do that, the animation controller is created. Now the way that we can actually view the contents of this controller is by switching over here to the animator tab. You can also access this tab by choosing window and animator. Again, take care because there's another window called animation, which refers to the legacy system. You don't want that, you want the animator. So I'm going to switch over to the animator tab, and you can see that we have this state machine defined here. Now I'm just going to shrink the object inspector as far as I can. I'm going to shrink the hierarchy panel as far as I can, and this also the project panel, I can't shrink that anymore. So what I'm going to do is I'm just going to grab this tab for the animator and dock it over here so that we can see the scene view and the animator all in one here, and that sort of makes things a bit clearer for us. So we have this animator window here, and I can hold down the middle mouse wheel on the mouse button here to sort of scroll around this tab like so. So we have this animator, and this controls the logic for the animation. Now right now if I press play on the toolbar, again we can still see in the viewport that the character is not animating. What we need to do first is to select the character in the scene, and you will see that for the animator component we have this controller field where we have to specify an animator controller to use for this character that's going to be controlling the animation logic. To do that I'm going to drag and drop my char controller onto the controller field and release, and now this controller is associated with this character. Again, if I press the play button on the toolbar, we see something has changed. The character is now in some kind of default posture, but this is not what we want, and still it's not animated, but we are making progress. So I'm going to press stop on the toolbar. Now let's say, for example, I want the character to be in its walking pose. Well, okay, we can do that quite easily. I'm going to move over here to the meshes folder, open up the character folder, and open out our character mesh, and you can see that we have the animation clips we've defined earlier, the idle, cheer, the walk, and the push animation. So I want to make the walking animation the default one. I can click and drag that into the animator window, and now I've loaded it in, and you can see that it's colored orange. It's colored orange because it's the default animation. We've defined the animation to be loopable. So now when I press play on the toolbar, you'll see now the character is walking along, and you can see that the animation is playing repeatedly. If I switch to the scene tab, you can see that the character is just walking off into the distance, and that really isn't what we want at all, because we want the character to walk in place. We want him to walk on the spot, and we want to control his movement independently. We don't want the animation controlling that. So we can easily fix that. I'm just going to press stop on the toolbar and switch back to our character into the scene. You can see it here. I want to ensure that apply root motion on the animator component. I want to make sure that apply root motion is not checked. So I want to remove that tick box there, switch back to the game tab and press play on the toolbar, and now the character is walking in place, and that is looking good. We've got this character walking and he's remaining on the spot. Okay, he's walking through the floor just a little bit, but we can raise the character up into the scene. That's not too much of a problem. So ensure that you remove the check from apply root motion. So we've got the character up and running and walking. Of course, we don't actually want the walk animation to play by default. Instead, we want the idle animation to play instead. So let's just come in here, select the walk animation, delete that. Yes, I want to delete it. Let's drag and drop the idle animation into there. That is now going to be the default. I want to press play on the toolbar, and now the character is standing in the idle posture in the scene. You can see from this progress bar, so long as this character here is selected, you can see the idle animation is playing on a loop. We've reached the end, it goes back to the beginning, it's playing again, and the idle animation is playing. So that's how we can get started at animating our character in the scene. In the preceding movie, we created an animator graph that would put our character into the idle animation state as soon as the game began. But of course, we don't want the character to remain in the idle state throughout the entirety of the game. They should change state to the walking and the pushing state depending on what's going on in the game. In other words, we need to change the state of the animation when certain conditions occur. And what I want to do now is to consider the animation graph further to implement those conditions so we can get the character animating into different states. And we're going to be using the animator window here to do that. So let's consider what we have. Right now we have the idle node, which is coloured orange, meaning that it's the default node, so that when playback begins, if I press play on the toolbar, we see that the character immediately enters the idle state, and this state loops indefinitely. So this is pretty good, it's what we want to do, but there will come a time when the character has to move forwards, and when that happens we want to play the walk animation. So what I'm going to do to control these states is create a parameter, and you can see down here in the bottom left hand side of the animator window we have a parameters section. I want to add a new parameter, so I'm going to click the plus button here, and I want to add a new integer parameter. So I'm going to select int from the menu here, and I'm going to name this parameter iState to indicate that it's an integer variable and it controls the state of the animation currently being played. Now I'm going to assume that a value of 0 means that the character should be in the idle state, a value of 1 means the character will be walking, a value of 2 will mean they're pushing the box, and a value of 3 means the character is cheering. So when these values for this state here change to those numbers, the animation state will change. And of course later in this video we're going to be coming along and adding some script to this that integrates directly with this graph and controls this state value to change the animation state currently being played. So what I want to do now is to create a new transition. I want to set up this idle state here so that when the state variable changes from 0 to 1, it's going to change to the walk animation. So to do that I'm going to unravel the character mesh here and drag and drop the walk animation into the graph and just move it over here, and I'm also going to drag and drop the push animation into the graph and move it over here. Notice that in adding these nodes, if I still press play on the toolbar, the character is still in the idle state animation. Adding these nodes to the graph hasn't changed anything, because right now we're in the idle state and the character never changes from that to any of these other states. Of course I could select this walk animation node, right click and choose set as default, and now if I press play on the toolbar the character is walking because this is the default node. And again I could do the same for the push. I could choose set as default and press play, and now the character is pushing the box. So I'm going to switch back to the idle and set that as the default. And I want to create a transition now, so I want to right click on this and choose make transition, and now I get this arrow that I can connect to a different node, and in particular I want to connect it to the walk node. So I want to change the animation state from the idle state to the walk state when this iState value changes to 1 or changes out of being 0. So I'm going to show you how to do that, how to configure this link to this walk state in the next video. So in this video we're going to continue configuring the animator graph here to manage between these different animation states according to the iState variable. I've gone ahead here and started with the idle state and created a link to the walk state, which configures a transition between the idle state to the walk state. Let's now just press play on the toolbar and see what happens. The character standing still, again you can see the idle animation playing, it reaches the end and then suddenly it enters the walk state. So the character was standing still in idle, the animation played once, and then when it reached the end, it quickly went over to the walk animation, and now the walk animation is playing on a loop. Let's see what happens now if I move to the walk state. I right click and I choose make transition, and then I click back on idle. So notice now the arrows here indicating the direction of the transition. We begin in idle, we then complete the idle animation by playing it once, we then move to the walk state, and then let's see what happens now. We begin with idle, this is playing, it reaches the end of the animation and enters the walk state. That plays once and then goes back to idle. And now this plays once again, and when it ends, it returns back to walk, and it continues on this loop. So by default, what's happening is each animation is playing once, and then it's moving to the next animation and moves back. And we've created this kind of looping logic here. So I'm just going to stop this here and take a look at the connection between the idle to the walk state. You can see here in this playback window that in this window, this range here, what we have in this range is the transition between the walk animation and the idle animation. So when I press play, you can see the transition occur here in the playback, in the viewport. You'll notice that the conditions for this transition, the conditions that trigger when the idle state changes to the walk state, the condition is the exit time. When the exit time of the animation, when playback equals 0.96, 96% of the idle animation is completed, and then it will transition to the walk animation, and that is the problem. That is not what we want. We want to remain in the idle animation until the iState variable changes to 1. It's only then that we want to transition to walk. So let's select this transition here, the arrow pointing between idle and walk, and change the conditions here. We want to change this from exit time to iState. And I want to say when iState equals 1, we will then transition to the walk animation. And for the parameter connecting the walk animation to the idle animation, I want to say when the iState is not equal to 1. When it's not equal to 1, then it will transition back to the idle state. So now let's press play and see what happens. So now we've got the character, it's in the idle state, and it's reaching the end, and again it loops back to the idle state. This idle state is now playing on a loop because iState is 1. But of course, let's just select the character so we can see the character. We have the character selected here in the viewport. We have this iState value, and when this changes from 0 to 1, the walk animation will play. So now I've set it to 1, and now notice the walk animation, it's playing, just as it should according to the logic of our graph here. So I'm going to change it back to 0, and again now the player is just standing still in the idle state. I can of course change it back to 1, and again, ta-da, the character is walking. Splendid. We've got the beginnings of the animation logic set up now. In the next video, I'm going to be completing the animation graph. Now before completing the animation graph, let's just take care of some things that are getting on my nerves. In particular, right now we've got this grey temporary cube in front of the character, and I really don't want to see this at the moment. We might want to see it later when we're importing our main cube objects into the scene, but we're not doing that now. Right now we're trying to focus on the character, and this box is just getting in the way. So to hide this, because the box is being modeled as a separate object, separate from the character mesh, we have independent control over its visibility. All we need to do to hide this box is to dig down into the hierarchy and select the P-cube mesh, and we can just switch it off completely. And now we can't see the box mesh at all, and we can just focus now. When we press play, we can just focus on what the character is doing. So if I switch to 1, again now the character is walking, and we don't have to worry about this box being animated with the character. So that's looking pretty good. I'm just going to raise the character upwards just slightly in the viewport. The feet are just penetrating through the floor there, so I don't want that. Just press play, and switch that to 1, and now that's looking much better. So that's what we want. So we have this character, and we've started to configure this animation graph. We also want to configure this for the push state as well. So I'm going to select idle, right click and choose make transition and set this here, select this transition. I want to change this condition from the I state when it equals 2, because 2, when I state is 2, that represents a box pushing state. And again, create another transition back to idle and say when I state is not equal to 2, then we want to transition back to the idle. So now I'm going to press play on the toolbar. Again, the character is in the idle state. I want to change this to 1 and the character is walking. I'm going to change this to 2 and see what happens. And now the character is in the box pushing state. Let's just switch to the game tab. You'll notice that right now, when the character enters the pushing state, they are raised above the floor. And that's not really what we want. Let's just change back to state number 1. You'll see the character's feet are on the floor. But again, if we go to the box pushing state, the character is hovering slightly above the floor. So how do we fix this? Well, one way we fix this is by selecting the mesh here in the project panel and switching over to the animations tab and selecting the problematic animation. In this case, the problem animation is the push animation. So I want to select the push animation, and you can even see in the preview here, if I go back to walk, you can see the character's feet are on the ground, but in the push, again, the character's feet are above the ground. So we can easily fix this by moving downwards here to the transform position Y and changing this offset. I'm just going to set this to 0.2, and I think that's about right. Now the character's feet are on the ground. So you can actually offset the Y transformation here, and I've set that to 0.2, and I'm going to apply those changes, choose apply. And now when I press play, let's change to the scene tab so we can see the character clearly. Press 1 and he's now walking on the floor. Let's now press 2 and the character is now pushing and their feet are firmly grounded, which is what we want. So that's how we've corrected for that inaccuracy there on the Y-axis. And in doing that, we've now completely configured the animation states for our character, the idle, the walk and the push, and these are controlled by the iState parameter. Right now, while the game is running, we're having to come in and change this iState value manually by typing in the values here, but of course we're going to be accessing this parameter directly from script when we come along and implement the player controls, so that we'll have complete control over the animation state that's being played at any one time. And we're going to consider the issue of input controls next. So now we've created the animation graph that we can see here that contains the idle, walk and push animations, and together these control the animation logic of the character using the iState variable. And what I want to do now is to create some input mechanics for the player, so that when we press different buttons on the keyboard, we control the movement of the player and the animation that plays. In particular, I want to create a script that interacts directly with this iState parameter. Now, the script I need to create for this is quite lengthy, so what I've done is I've gone ahead off screen and already created the script, which I've created here, named Player Controller C#, and I've dragged and dropped that onto the character and added it as a component. You can see the player controller here, and what I'm going to do now is to open up the script file and go through the main features of it with you to explain what it does and how it works. So I'm just going to jump over here to MonoDevelop to see the script file we've created. So here you can see the first thing that I've defined for this player controller class here is a move type enumeration, which defines the idle, walk, box push and cheer animation states for the character, and these are identified by 0, 1, 2 and 3, which correspond to the iState parameter in the animation graph. Now I'm keeping track of this variable using the player state property that I've defined here. It's a public property, and by setting and getting this player state, I can control the current state that the player character is in. So if I want to make the player character in the idle state, I can set player state to idle, or I could set it to walk to activate the walk state. You'll notice here in the set function for the property that I call this line here, which is animcomp.setInteger, and this line is absolutely critical to working with the animation graph. So let's see what's going on here. If I scroll down slightly further, you can see I've created at line 38, I've created a private variable called animator animcomp, and I initialize this variable in the start function here. You can see on line 47 that I use the getComponent function to retrieve the component animator. Now if I just minimize MonoDevelop, you can see if I select the player character here in the Object Inspector that it has an animator component, which is where we've defined the animation controller and we control the main animation logic. I'm getting a reference to this component so that I can control it. So I'm going back to MonoDevelop here. So here in the player state variable, I'm using the animcomp.setInteger, and what this function is doing is it's actually directly accessing the iState variable in the animation graph, and I'm passing it the state value, the current state that the player is in, which could be 0 for idle, 1 for walk, 2 for box push, or 3 for cheer. This is the place where we update the animation graph and actually control which animation is playing. The rest of this source file is related to really handling the movement of the player throughout the level. So right now I'm going to come back to this code, but right now let me just minimize this and let's just press play and see what's happening. So when I press play and I press the W key on the keyboard to walk forwards, you can see the player starts walking and we update that iState variable, and when I release the key we go back to a value of 0, and that really is this player state property taking effect. So that's how player state works. Next I'm going to scroll down and explain what some of these other features are doing and how they work. Now in this video I want to consider player movement specifically. You'll see we have our character in the scene here. Now there are several ways we could implement the movement for our character. In particular, there are two main ways. One way is to create a completely free-form movement for the character, as we might find in many third-person 3D games. This movement allows our character to rotate around to practically any angle, like so, and to walk forwards in practically any direction. So let's just change this to a local axis, and we could move forwards this way, and then we could rotate a bit more and move forwards that way. And it's completely loose and we can rotate and move in any direction at all. Now we could take that approach, but I'm not going to do it here, because here really we want to try and constrain player movement to a very rigid up and down, left and right grid, because otherwise that might damage the main game mechanics for a box pushing game. We don't want the player to start pushing boxes at an angle. The idea is that they can push boxes forwards, backwards, left and right in the 4 cardinal directions. These kind of incremental controls, these rigid grid fixed controls, are similar to games such as The Legend of Grimrock, where whenever the player turns and rotates, they rotate in a discrete increment. So he'll rotate 90 degrees this way, and if we choose left, he'll rotate 90 degrees that way, and if he moves forward, he'll move forward in a discrete increment and stop. So that's the kind of controls that we're going to be implementing in this, a kind of railroad control that constrains movement to particular axes. So what I'm going to do is I'm just going to return back to the main view here and jump over to MonoDevelop to take a look at our main movement code. So we're back to our code here, and I'm just going to scroll down here to the start function, and you can see that the first thing I do is I call a coroutine handle input, which is this coroutine beneath here, and this will be called on each and every frame. It's going to loop forever and be called on each frame to check player input. And effectively what I'm doing here on line 59 is I'm saying if the player is pressing the forwards key, then we want to set this state to player walk, and we're going to initiate another coroutine that will move the player forwards in the direction they're looking at by a specified increment, by the move distance. And if I scroll further up, you can see that by default the move distance is set to 2 world units, and it travels that over the case of move time. So for example, every second for move time, we're going to travel 2 units in the direction that we're looking. So what will happen is the handle input function here will initiate the move coroutine to move the player. And the move coroutine is specified here. It takes them from their current position and moves them forward over 1 second by 2 units. So once that's completed, it then checks to see is the player still pressing forwards, and if they are still pressing forwards, we'll move forward again another 2 units. And in that way, the player will always move in specified increments in the direction they're looking. I just so happen to know, if I just minimize MonoDevelop, that the general width of one floor tile in the level is 2 units. So if the player is standing in the middle of, say, this floor tile here, and they walk forwards in this direction by 2 units, they will end up at the middle of this floor tile. And again, if they move forwards from this floor tile by 2 units, they'll move to the center of this one. Or if they rotate and face this direction and move forwards, they'll move forwards to the center of this floor tile by 2 units. So they're moving tile by tile, and that's what we want, because we want to constrain the movement of the boxes according to the general sort of grid arrangement that we have here. And if I go back to MonoDevelop, this is what this move function does. It allows the player to move forwards in the direction they're looking. You can see here we're using the forward vector of the object. So the forward vector is this blue arrow for the player here. Let me just switch over to the player character and take a look at them in the scene. You can see that the player is facing in the direction of the blue arrow, which refers to the Z-axis that you can see here. That represents the forward vector of the player, the direction in which they are looking. So if the player was looking in this direction and I was to press the W key on the keyboard, they would move forwards in this direction. If I were to rotate by 90 degrees and press forwards, they would rotate in this direction. So that's the way the movement generally works. And if I press play on the toolbar, actually let's just maximize this, and I press forwards, the player is going to move forwards. Actually, I'm in the scene viewport. I need to switch to the game viewport. Let's just stop this, switch to the game viewport, press play, and now I'm going to press W on the keyboard, and the player moves forward and stops by 1 increment. So they've moved forward 2 world units. Let's just see this in action. And what I'm going to do temporarily is take this camera object, and I'm going to drag and drop it under the player character, so that now the camera will follow the player character because the transform will cascade downwards. So let's just maximize the game tab, press the play button on the toolbar. I'm going to hold down the W key to move the player forwards, and you can see them moving forwards. Again, we're continually moving forwards until I release, and then the player stops. So that's how that sort of generally works. Let's just take the camera out of that. And so right now what we can do with this code is move the player forwards in the direction that they're looking. And in fact, let's just go to the scene viewport, select the player character. Let's just rotate them 90 degrees, actually negative 90 degrees this way. Parent the camera to the game character, switch to the game tab and press play. And now have moved forwards. You can see the player character is walking nicely through the level. So there we have it. Right now we don't have rotation controls just yet. I'm going to be implementing all of the rotation and the collision detection mechanics in the next volume of this course. Right now I just want to show you how you can get some code in here to switch between the animation states and to move the game character. So that basically is how this code works.